Welcome back to the channel. In today's episode, we're going to be doing something fun, important, and most of all, kind of difficult. So that's going to be picking up physics objects, moving them around, being able to actually manipulate them, being able to drop them with the left mouse button in this example, and throw them with the right mouse button. And yeah, let's get started. Well, first of all, I'm Rembot Games. I make video games on Steam. Check out Unaccessible, DJ Simulator, Let Me Book. If you like rage games, then you'll really enjoy this one. Or if you like scary games, come check out Let Me Book. Also, stream on Twitch every other day, so come check that out. Otherwise, just like and subscribe, because it really does help out the channel. And comment if you really want to support. Also, the files for this project will be up on my Patreon, as well as the game files for most other tutorials that I do. That you can get for the low price of $5. You can download all of these templates, basically. Like the Steam proximity chat one, right? Anyway, we're going to get into it now. So, in Godot, we're going to create yourself a new scene. We're going to call this one main scene. We're going to hit Control S. We're going to save it into a new folder called scenes, just to keep things neat. You know how I am. First things first, we need to create a CSG box, which is going to represent our floor. I'm holding Control and Shift while I'm moving this box, so it moves every 10 centimeters. And then I'm going to go 20, tab 20, make sure it's a 20 by 20. I'm also just creating a quick new folder called images because of this grid material that I've dragged in. And then what I'm going to do is move that into the images folder and drag that directly onto our CSG box. Come on. Then I'll click the CSG box, go to the geometry, and then over here we're going to actually go down to the UV1 and then set that to triplanar. And now we get a nice sort of grid to work with. I'm also going to change the sampling over to nearest bitmap anisotropic, and that's just going to make it a little bit more aliased for us. So I've just hit F5 to start the scene. It's going to go gray if we try and start this, but I'll start it anyway. See, just straight up green. And now what I can also do is turn off these little options here. I can go to the project settings, change this to 1920 by 1080, and I'll also make this full screen because I think the full screen is a little bit better. So it's completely gray, that's fine, that's what we expect, right? Because we've got no player. So we're going to create the player by RigidBody3D here. I'm going to rename it with F2. Go player, and then what I'm going to do is right click immediately, save branch as scene. We'll call that player, make sure we're in the scenes folder. And then inside player, what we need to do is we need to add a collision shape, 3D. Remember, it's Control A, or you hit this little plus button to add a node in. Now we're going to go capsule shape, like our little bean. I'm going to set the radius to 0.25, the height to 1.8. A half of 1.8 is 0.9, so we're going to put that in the transformation Y just to move the player up a little bit. Now I'm going to go back to the player. I'm going to type in camera 3D just to ensure that it is a parent or a child of that player and not the collision shape like we had selected a second ago. I'm going to hold Control and Shift and drag this gizmo up till we see about 1.6 down in this corner here where my head is in the Y direction. So we'll do that again. 1.6, that's about the height that I like it at. Some people prefer 1.5, but I think it's a little bit too low. So now we're going to need to create a little bit of boilerplate code for this. We're going to run this scene. I'm going to fall through the ground. No, we don't have gravity yet. Okay, so speaking of falling through the ground, this CSG box 3D, we're going to go turn the collision on. Make sure it's on collision layer 1. So we're also going to take this opportunity to name these layers. So we've got world player, and then what's the other collision that we need to take into account is going to be our rigid object. So we're just going to call it rigid, right? Or rigid bodies. So now we've got those 3 collision layers set up. What we can do is we can go to the player, and then we can actually create a script for the player. I'm going to switch it over into another folder, scripts, just to keep things neat. Bam. And then if you've got that template button selected, then it'll create this template. If you did it wrong, you can just do it again, or you can pause the video and copy paste this, but I wouldn't recommend it. Now, input map. We don't want to use UI left, right, up and down because those are the arrow keys. So what we're going to do is we're going to create our own input map. Usually I type move with underscore, so then I can go, and then I copy it. So I can go move up and then paste, move down, move left, move right. And then over here, you're going to hit W, S, A, and D. And now we've got our input map. But we also need two extra additional input maps, right? So one of them is interact, which at the moment is going to be our left click, but you can change it to E or F or whatever. And interact 2. So interact 1 is going to be left click, and interact 2 is going to be right click. And yeah, like I said, you can change that at a later date if you want, but interact 2 is going to be our throw. In fact, yeah, we're just going to keep it as interact 2. That's fine, because we might want to change it at a later date, right? And also, like, two inputs can also be the same thing, right? Okay, so once we've done that, we're going to go over to here, the UI up, UI down, UI left, and UI right. We're going to hit backspace and then type move. So I just held Alt when I clicked, by the way, and it means that you can put crazy things all over the place, all at the same time. Cool, so now that we've done that, we should be able to run the game and be able to walk around with WSAD. Fantastic. And the next thing we've got to do is add the mouse movement. So input, right? So if we go if event, I'm just going to make this a little bit bigger, and we're also going to need to do a little bit of work on the player now, but the basic idea is we go if event is input mouse motion. We can go event.relative. Is that how you do it? Oh, if event is event.relative.x. I think this is how it works. Yeah, event relative x. So that's basically our mouse movement left and right. And what that's going to do is that's actually going to rotate our character on the y-axis, right? So if we just want to set that up real quick, we'll go var x float equals, so that's going to be our x rotation, and then what we can do is we can just go rotate x, and then the x rot times what, the delta? We don't really need the delta, we want it to be precise, and there is no delta, right? So if we go look left and right, yeah, you can see it's doing something. So it's not rotate x as well, it's rotate y equals the x rot. Y rot, yeah, there we go, y rotation, and then on the rotate y. It gets a little bit confusing because the x is rotating the y, and then the y is rotating the x to look up and down, right? So it is a little bit confusing. Now what we want to do up here is we want to go var mouse sense. That's going to be a float, and it's going to equal 0.01, I think, or 0.1, I can't remember. So what we do is we get that y rotation, event relative x, and times that by the mouse sensitivity, and then you see it's inverted. So what we've got to do is we've got to go negative event relative dot x times mouse sensitivity, and now we've got being able to look left and right. So the next thing we've got to do is actually create a head, because we don't want to manipulate the camera directly. We want the camera to be sitting at 0, 0, because in case if we ever want to do like a head shake or anything like that, we can manipulate the camera directly and it's not going to interfere with other things. So what I've done just there, and this is a really good tip, is on the camera, if I wanted to reparent the camera, right, to a new node, what it would do is it would create that new node at 0, 0, right? So then this becomes the head or whatever, right, the pivot point, right? So instead what I do is I click on the camera 3D, I go Control A, and I type node 3D, and then it actually creates that node 3D at the exact same position as the camera 3D, right? So the ultimate goal here is to actually be able to zero out this position, right? So what we're going to do is we're going to drag this node 3D up, we're going to rename it to head, and then we're going to drag the camera 3D into it, right? And now when we manipulate head, it'll manipulate the camera. The camera 3D has had all of its transformation reformed, and all of that is now part of the head, right? Fantastic. And now we go back into the script, and then what I'm going to do is I'm going to grab a reference to the head here, and then over here what we can do is we can get our, so that also, by the way, that's Control Alt down. That's how we duplicate lines, by the way. So Control Alt down, and then I'm holding Alt and I'm pressing down, and that's how we move the lines up and down, right? So then what we need is our, what is it called? It's a tilt. So we call it the X tilt. Yeah, we'll call it the X tilt. This really shouldn't be Y right. We really should have better names for this stuff, right? But it doesn't matter. So X tilt is the relative mouse motion Y times the mouse sensitivity. And then we're going to get the head, and then we're going to go head.rotate X, and then that's going to be the X tilt, right? Row 8, yeah, right. We're not spelling it right. Head.rotate X. Look, and now we can look up, down, left and right, and all over the place, right? So this mouse sensitivity, I'm also going to make half of what it was before. Yeah, that looks way better. And now you'll see your mouse is still moving around on screen. So what you want to do there is we want to create a func input. No, ready? Yeah, so on ready, what we want to do is input dot set mouse mode, input mouse mode captured. And then what that does is it does that thing where like every frame it puts the mouse back into the middle of the screen, so we can never escape the application unless we move our mouse really fast. But I don't think that's ever going to happen. Cool. So there we go. We've got a basic player controller, and it's set up exactly the way that we want it to at the moment. So what do we have to do? First of all, we've actually got to be able to detect something on the ground, right? And for that, we're basically going to need a shape cast. So some people will use a ray cast. I prefer a shape cast because we've actually got, say, a little sphere on the end of it that's going to decide what to grab. It's like a ray cast, but at the end of it, it's got like a collision shape, so it can touch things to the side of the ray cast, right? That's what our shape cast is. Now, by default, it actually points down. You can see that there, right? It's pointing down. So what we want to do is we want to zero out that Y dimension on the shape cast, and then we want to go -1 in the X direction, and then we can see that that shape cast is now pointing out 1 meter in that direction. So actually going to change it to 2. Just so we've got a little bit more room to work with, or even -2.5, because the further away it is, the more QOL it feels. But when it gets too far away, it just feels like you're a magician, right? So the shape cast, and now what we need, right, is we need a position for, let's say you pick up that object, we need a position. So you detect the object with this, right? And speaking of, on that shape cast, we're going to make this collide with, right, this collision mask is going to be 1, which is the world, because we don't want to be able to reach behind walls. And also number 3, which, if you remember, is our rigid shapes, right? Which means this is going to be able to detect, as long as bodies is turned on here, it's going to be able to detect our rigid bodies, right? So the next thing we've got to do here actually is create a spring arm. Right, and the reason for the spring arm is just because we don't want it to go through walls, right? So over here with this collision mask, we're going to make sure that it's only going to avoid, actually, what do we want it to do? We don't want to select player here. We could select rigid as well, depending on what it looks like, but it's going to look a little bit weird when we have it held in our hands, right? So this spring length here, we probably want that at about 1.5. We need to see if this is actually facing the right way. So on that spring arm 3D, I'm going to create a little CSG sphere, just a tiny little sphere. And this could just be a mesh instance or something. I just need to use something to actually be able to see what I'm looking at. So 0.05. And now if you run that, yeah, so it's behind me. Okay, cool. Our solution to this is we just grab this spring arm, and then I'm just going to rotate it 180 degrees. Right, so it faces this way. Now, you're not really going to see what happens, but look, our little CSG mesh, which we're actually going to turn red real quick. Just go to our albedo, and we're going to make it red, just so you can actually see it, is going to be floating in front of us, right? And it doesn't look like it's going to because it's at the exact same position as the camera, but what the spring arm does is it detects things, and then it's like a spring, right? So if I was to set this spring arm to, instead of being 1.5 meters, if I set that to 10 meters, I'll show you what that's going to look like, right? So you see our little dot in the distance, but then when I look at the ground, the dot comes closer to us, and that's because it's being sprung from the ground, you know? It's trying to push through, but it can't, you see? So it stops there. And basically, that's how we're going to ensure that when we're holding an object, it's not going to go through a wall. We're not going to be trying to push it into a wall, right? So that's how we do that. I'm going to set it to 1.5 meters, right? And then instead of having that CSG sphere there, I'm going to turn that off, and I'm actually going to go to the spring arm. I'm going to add a marker 3D. I'm going to hit F2, and we're going to call that the object anchor. Or we're going to call it the grabbed anchor. Yeah, grabbed anchor. Cool. And then so what we can do is we go back to the code. We're going to get that grabbed anchor because we actually need to know the position of that for this example, right? So that's it. The idea is we detect with the spring arm. We detect with the shape cast. We want to move it to where the spring arm ends, and then that's how we'll know that we're holding an object in front of us, right? Now the thing about rigid bodies is they don't act the way that you think that they would through code. So I'm just going to create a new scene. We're going to call it, what do we want to call it? Box. Rigid box, because it's just going to be a box, right? So we're going to use a collision shape 3D because it's a rigid body. We need to have a collision shape. Just going to add a little 0.2, 0.2, 0.2 size box, just a little box for us to be able to pick up, right? And then I'm also going to add a mesh instance. Then I'm going to go box, and we're going to copy those dimensions. And then we're going to save it into scenes as rigid box. Now over on rigid box here, I think really what we want to do is we want to create a new script for this box. But what I'm going to do right now is basically nothing, and then just go class name equals rigid box. And so what that's going to do is that's going to be easy for us to identify what's a rigid box versus what's a rigid body in code. So over on the main scene, I'm going to go Control Shift A, and then we're going to go rigid box. So what Control Shift A does is it lets you import scenes instead of nodes, right? And now when this falls, it's going to fall to the ground. So as well, I'm going to just quickly add these two environment things so we're not in a completely dark, shitty environment. I'm going to grab both of these like I usually do. Reparent to new node, I'll just choose a regular node, and then we'll change that to environment. Cool, and now we have a little environment set up for us to walk around in. So this box as well, maybe we'll change the color to, not sure, what color do you reckon we should change it to? Maybe green. Green works. We've already got red, right? Cool, so we've got that green. Got that green. All right, so we're walking around, we're sussing it out. Perfect. All right, and now we need a way to actually, detect that. So we're going to go to the shape cast, make sure that it's got 3 selected, which it does. Now we're actually going to go to visible collision shapes, and then we're going to run that again with F5. And then you'll see it's colliding with a lot of stuff, as it should, right? It's actually, is it colliding with itself? What's going on here? Okay, so this rigid box, we actually, I don't think, set this up to be on collision layer number 3, meaning it is a rigid box, and all it sees is the ground, right? So if we've got a rigid box here, we walk into it, we're pushing it around, we're pushing the crap out of it, right? Because our player is still on layer 1. So we're going to go over to player, make sure that our player is set to layer 2. And now when we walk around, it shouldn't even see it. We should just walk directly through it, right? So we've got 3 different collision layers. We've got the ground, we've got the box, and then we've got our player, right? So if we hover over this box right here, you can see that that goes red, and that means that we're actually colliding with something. It's also going to go red when we're colliding with the ground, and that's fine. Like I said, we don't want to be able to reach through walls, right? And that's what that prevents. Cool. Now we can finally move on to the grabbing code. So first what we want to do is we want to go var grabbed object, and then that's going to be a, well, we can put rigid box here if we really wanted, but we're probably just going to go rigid body just in case you have other items that you want to be able to pick up, which you probably do. Grabbed object equals null for now. just to drive the point home that we don't actually have anything picked up right now. So then when we look at something, right? So on this input event, right? So we go elif event is input event. And now we're using mouse buttons, but if you put it on E or F, you know, you interact 1 or 2 on E or F or another keyboard button or joystick button, then it's not gonna, or joypad button, it's not gonna be this. This is just because it's a left click or a right click, right? So first we have to check if input is action just pressed interact. And then what we're gonna do is if grabbed object, then grabbed object equals null, because basically the way that we're going to move the object around is if you've got a grabbed object, every physics frame it's going to be moving it to that little red circle, right? So the way that we drop items is we just remove the reference to the grabbed object and it'll just fall the next frame. Now the other thing we've got to do is make it throw away from the player, but we'll work out that later, right? Cool, so then this shape cast, we're going to call it object grabber shape cast, right? We're going to go stick it up the top here underneath the grabbed anchor. Object grabber shape cast, and then what we want to do is elif dot is colliding. So if it's colliding with something and we've clicked interact, the next thing we want to do is figure out if we're looking at a rigid box or not, or if we're just looking at the ground, right? So what we're going to go do is var collided equals object grabber shape cast dot get collision result. Is that it? Yeah. Just control click to make sure that's real. Yep, just get collision result. Yep, it's a thing. And then I think this pumps back a list if I'm not, yeah, so it's an array. So what we've got to do is we've got to get the first object out of the array because we don't want everything else. And then I think what happens is we need to get the collider like that, right? So we're just going to check here. If we go print collided, now if we walk up to this and then we click, we should have had, yeah, we've got a whole bunch of debug stuff right here. So we've got CSG box, rigid box, CSG box, rigid box, right? Because the shapecast is detecting the ground and the rigid boxes. Not the players, but the ground and the rigid boxes, right? So next what we've got to do is we've got to check to see if it is a rigid box, and if it is, then we grab it, right? So we go if collided is, this is the way it works, if is, not equals, is rigid box, then we're basically going to need to create a function here, right? If not grabbed object, we need to try grabbing. So we're going to add a function here. So I'm just going to create this here. I'll try grabbing, and then we're just going to pass this. Come on, mate. Come on, mate. Cool. So then if grabbed object, then try grabbing, right? Or if not grabbed object, because we don't want to ever grab an object if an object is already grabbed. Otherwise, we'll be grabbing the object that we were already grabbing, and that's not good. So here we could go elif collided is static body, you know, and then you could continue the logic like this, right? So if you had other things, not just rigid boxes, but other things, this is how you would continue the logic of picking them up, right? You would do it sort of right here, but we're not going to need that for now. So I'm just going to delete that. And then what we'll do is come back to this one here. So this is elif input dot is action just pressed interact 2. So this is going to be our throw, right? And then what we need to do is if grabbed object, then throw object. And that's also a function that we're going to need to create right here. So func throw object and func try grabbing. And also I should have mentioned before that like our FPS controller isn't that great. Like you can do stuff like this. The point I'm trying to make here is these are the bare bones that you need to actually create this kind of interaction. Man, that hurts my head. Cool. So our try grabbing and throw object. Now the grabbing, we already know what it is here, right? So if it's a rigid object, I guess we could actually just pass this directly into here. So this is going to be a, it's going to be a rigid body. Yeah, it's going to be a rigid body. And then what we need to do is just to go grabbed object equals collided, right? I think that's how we're going to just grab it. And then on throw object, we also need to do the same thing. So grabbed object equals collided. No, we do the opposite. We go grabbed object equals null. But before we do that, we actually want to add an impulse to it. So what I'm going to do is apply impulse, and then because it's a vector 3, we're going to need to work out like a global basis of the camera, etc., etc. But what I'm going to do is just throw it with 5 meters of force, whatever the hell this works out to be, up, right? So let's try this. Now we walk up to it, we left click, it should be grabbed, technically. And then yeah, when we right click, when it's grabbed, it throws it up in the air. So we can see that it's actually working. But now what we've got to do is we've got to work out on the physics frame, we actually need to move that grabbed object to that position. And so just to reiterate, that position is going to be where this little CSG sphere ends up, right? So basically we're going to click this and then it's going to move to where that CSG sphere is, okay? So just as a little bit more of an example, I'm going to duplicate this little box here, and then I'm going to add in just like a little obstacle, like a little wall that we can walk up to and try and poke this shit through, right? So I'll show you what I mean. So we can walk up to this wall and you see how that red object gets bigger because that's our spring arms. So spring arms, honestly, they're really, really handy as long as you know how to use them. And then they save you so much code, honestly. So that 1.5 meters, I think, is a little bit too much. We're just going to set it to 1 meter. We're going to see what that looks like. It might be really big, but I think it's also quite close, you know. So if we grab it, it's actually got somewhere for that box to move. Awesome. So we're going to do player. On the physics process, this is where the real magic's going to happen, right? So that anchor, the grabbed anchor, right? Here we go. So after the move and slide, we need to go if grabbed object, right? So on the physics frame, if grabbed object, and we basically need to move that rigid body. So I'll show you what I mean by it doesn't work nicely, right? So if we just go if grabbed object dot global position equals, what is it? The grabbed anchor dot global position. This is basically how you would expect it to work. And if it wasn't a rigid object, then this would work, right? But it's dodgy. It doesn't always work. It's a little bit sketchy. You see, like things like this happen. It's not good. And then when I let go of it, it just pisses off entirely because rigid bodies were not meant to be manipulated like that, right? So what we actually have to do is every frame we need to actually apply the amount of velocity that we need to get it to that position every single frame, right? So we can't just set the position directly. Now I'm going to show you again. See, if we pick this box up, you might think that it's working and it's all good, but if I left click, it just, see how it snaps to the ground because, look, and then it goes straight through the ground. And that's because like the whole time I'm picking it up, it's increasing its velocity because this is not the way that rigid bodies were meant to be manipulated, right? So get that idea out of your head. It's not going to work. Just follow this tutorial, trust me. So we're going to turn that off, right? And then what we need to do is get our target position. And that's going to equal the grabbed anchor dot global position. So this is going to be a vector 3. Vector 3, perfect. And we need to get our current pos. Target pos. Yeah, we're going to shorthand this just because then we know that it's not a built-in method later down the line, right? So it's going to be the grabbed object dot global position. So then we're going to go var direction equals, what is it? Target pos, take away current pos. Yep. We can't use the direction, so we got to create a new name for that. We'll just call it new direction. And in fact, no, what we can do, see, we've got direction here. That's why we can't use it again. So what I'm going to do is change this one. We're going to change this one to move direction. See, I don't like that it's sharing a name there, so I like direction here. So then var required velocity equals direction times delta, no, divided by delta. So we go var velocity correction equals required velocity, take away grabbed object dot linear velocity. Yes, I have typed this out before. Grabbed object dot linear velocity equals velocity correction. No, required velocity. Yes, cool. Now that should just work. We also kind of want to add a little bit of damping to it, so it doesn't spin around, because you saw before, like, you can get it into a position where it's just going to spin like this. So we need to add a little bit of like angular damping, right? But look at this. So when we drop it, it falls down nicely. Not like before when it was, okay, it's gone. Remember when it was like freaking out, like when we were holding it, when you let go of it and we'll just shoot into the ground. It's not doing that anymore, which is awesome. So we need to go grabbed object dot, what is it? Angular velocity equals, no, times equals 0.1. So that's just going to slow down its rotation, right? So that means that if we hit it on something, it'll rotate. This is dodgy as fuck, but it's going to rotate and then it's going to stop, right? So there's our throw. We've still got our throw. And now the problem with our throw is it only goes up. So we actually need to make it go away from the player. So, you know, if we want to, so at this point, drop this up here, we can. So that's pretty cool, right? Pretty damn cool. So we need to get our throw script working. So apply impulse vector 3. We're actually going to keep that in there, but only a little bit, and I'll show you why. We're just going to delete that for now though, right? So we need to figure out which way to actually apply our impulse. So the way we work that out is whatever way we're facing, let's just go basis.z, negative basis.z, and then that should throw it away from the player, but that's not what's going to happen, right? It's actually going to go in the same way every single time. So basis.z times 2, I'm going to try that. We'll pick it up, and then we're going to throw it. We're going to throw it. Actually, that's pretty damn good. I thought we were going to have to use the global basis. Damn, that's all right. So we're going to times that by 5, just so we got a little bit of power. But you'll see what happens is if I look up and I try and throw, it's not going to throw up. It's just going to throw across, because we're getting the player's basis. We're not getting the basis of the camera. So what we can do is we can go camera 3D, or we can go head.basis.z. Right? So it throws it in the direction that the camera or the head is facing, right? But then we're going to get that problem where any way we throw it, it's actually going to go in a different way, right? And that's because the head doesn't change. It's at 0, 0, right? So what we need to do is we need to go global basis Z. And now if we run that, we pick this up and we throw, it's going to throw it away from the camera. It's going to throw it up, away. Geez, that's weird. So we're going to look backwards and we can actually throw backwards. That's disgusting. But we can jump, we can throw, yeah? We can pick things up, we can absolutely launch into the distance. But one thing I like to do when throwing these objects, right, is let's say I'm trying to precisely throw it over here. It's going to just fall down, right? It's just going to fall straight down, okay? So we're going to do a little bit of pirate softwaring, but basically this is your player right here. This is your Among Us player right here. And then when you throw, right, in the way that we're throwing, basically it's going to look like this, right? Our curve is going to look like this. It's just going to go straight down, right? That's what it's going to look like when we throw. But what we actually want to do is perhaps make it go like this, right? We actually want to get a little bit of distance and we want to throw it up just a little bit, right? Because that's a little bit more realistic. It's like you just don't throw it out. You throw it up a little bit whenever you're throwing. So the way that we add that is we need to add that vector crap back in there. So I'm going to grab all of this shit here, going to wrap that in brackets, and then I'm going to plus vector 3, 0, 0. And then this is where the magic comes in, right? If I throw a 10 there, right, and then we run it, it's going to throw it way up in the air. So I got to throw it, whoosh, it's like lobbing it, right? So you see the effect that we've got there. Now, if I run this with just 1, so it adds an extra 1, you see, we get a much more satisfying throw, right? Because it's not just throwing it where we're telling it to, it's actually throwing it with a little bit of lob, right? So we can actually, you know, get it up and over things, right? And it doesn't just fall straight down, right? So the next thing we can do, obviously, is we can just go turn off this CSG sphere so we can see it a little bit better. But, I mean, that's basically it, you know? That's basically it. You want to pick things up, move them around. I mean, another thing that we can do is go into the options and actually turn on physics interpolation, which is in physics common. We want to turn down the physics jitter fix, turn on interpolation. Then we're going to see a lot of this stuff actually acts quite a little bit nicer. Now, we might actually have to turn it on for these individual things, but I found that, like, I mean, a lot of it just kind of works, right? A lot of it just kind of works straight away. Interpolates the physics frame. Cool, so that's it. And if we want to add a little bit of damping, I think, onto the actual object itself, I don't think that this is the best way to do it, because you see, if we, so this angular velocity, what if we set that to 5, just so we get like a little bit of spin, but not a lot. Yeah, okay, so it's still going to stop it from spinning, which is cool, right? So what we could also do is we could make it so it angles itself based on the direction that the player is facing, right? But that's a whole separate beast. So that's the tutorial. I hope you guys enjoyed it. I think on the way out of this video, what we're going to do is I'm going to go to this main scene here. I'm just going to create a little script, and then we're going to bust in a whole ton of those little rigid boxes, right? So on ready, we want to go for I in range 100, right? We're going to get one of those little rigid boxes, which I'm going to drag over to here. I'm going to rigid box dot instantiate. I'm going to var new box, rigid box equals rigid box instantiate, and then we bod box. Then we're going to go add child to add it to the scene, and then we're going to go new box dot global position equals vector 3, and then we're just going to set it 10 meters above where it is right now. Cool, and then we're going to see what that looks like. Now, a whole bunch of boxes. Oh shit, should have just spawned out of nowhere. And now this is the problem with Godot's inbuilt physics engine. Sucks ass. Actually, no, they don't see each other. Okay, alright. So before we switch over to Jolt, if we have to, what we need to do is we need to actually turn on 3 on the mask so they can actually see each other. And you see, there we go. We got a whole bunch of them just fall from the sky, right? Now, let's change that to 1,000, and then we'll see how performant this is. So it's going to run 10 times slower than that last one loaded up. But we should still be able to pick all of these things up and move them around and manipulate them and all that kind of stuff, right? Oh, here we go. There we go. And then once everything freezes, we should get our frames per second back. All right, isn't that beautiful? A big heaving mound. A big heaving mound of rigid bodies, right? So have you ever played Mombazoo? I mean, this looks like the back of the Mombazoo ute, truck, whatever you want to call it. But yeah, look, I can pick objects up. I can place them with left click. I can pick objects up and I can throw them with right click, right? They can bash into each other. If I can actually land one of these shots. Yep, so they can smack into each other. Yep, cause a little bit of chaos. Perfecto. Now this is the easy way to do it. I know there's like a million other ways to do it, but this is the easiest way that I found to actually achieve this. Now, we could go a step further. I actually have it in my another tutorial of mine, which is like first person interactions. It's actually where we create an overlay that tells us, you know, press E to pick up or press left click to pick up. Right, so I hope this was useful for one or two of you. Come and join me in the Discord. We can come and talk game design. Come follow me on Twitch. I'm there all the freaking time. And a special thanks to my Patreon subscribers, which I am legally obliged to put at the end of my videos. So these are all my free users, all of my paid users. I appreciate all of you. Thank you guys for checking out, following me, and supporting my game development journey. Really appreciate it. So tune in, come join the Discord, chat shit. I'll see you guys in the next episode. And make sure you hassle a bunch of streamers to play Let Me Book this Halloween, because it is really, really scary, and it's really funny, and it's really challenging. And this is actually where I learned how to do all of this stuff. So picking up books, walking around, and putting them back into where they're supposed to go. So thank you guys, and I'll catch us next time.